Okay, let's talk about greatest common factor. Last year we talked about factors, and we had the factor ninja, and the ninja was like chopping our numbers up to make them smaller. So if you remember, factors are the numbers that we multiply together to get another number. So I'm going to be using the numbers 24 and 36 for my examples. Okay? I'm going to show you 3 different ways that you can find greatest common factor. Okay? The first one is just the simple method. It's just listing our factors and then finding which one is the biggest one that they have in common. Because what this means is the biggest factor that these 2 numbers have in common. Okay? We're going to be using this as time goes on to do different stuff. Okay? So last year we did factor rainbows, and so that's what I'm going to do here. So I'm going to find my factor rainbows for 24, and I'm going to do a factor rainbow for 36. Okay, so when I think of what numbers can I multiply together to get 24, well, I have 1 and 24. I don't think I left enough room for myself here. I have 1 and 24. I can multiply 2 and 12. I can multiply 3 and 8. I can multiply 4 and 6. And then I know that 5 isn't a factor. So my factors for 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Okay? Now let's do my factors for 36. Same thing, I'm just going to do my factor rainbow. So for 36, I have 1 and 36. I have 2 and 18. I have 3 and 12. I have 4 and 9. 5 isn't a factor, and then I have 6 and 6. Okay? So my factors for 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So I'm going to look for the one that's the biggest one that they have in common. Well, they don't have 36 or 24, they don't have 18, but they do both have 12 in common. So my my greatest common factor, my GCF, for 24 and 36 is going to be 12. So that's one method that we can do. We just list out our factors, okay? I have 2 more methods to show you. The other method has to do with what Mrs. Pendergast just taught you yesterday, the prime factorization. So where I'm going to break down all of my prime numbers, okay? So I'm going to make, this is called like the tree method. So I'm going to make factor trees for both of those. So I'm going to make a factor tree for 24 and a factor tree for 36. So what I'm going to do is I just start by any 2 numbers that can be multiplied together to get 24. I'm going to pick 12 and 2. Okay? 2 is a prime number, so I'm going to circle that. Well, 12 is not, so I need to break it down. It's going to get broken down into 2 and 6. 2 is a prime number, so I'm going to circle it. 6 is not a prime number, so it can get broken down into 2 and 3, which are both prime numbers. So my prime factorization for 24 is 2 times 2 times 3 times 2. Now, commutative property tells me that this can be in any order as long as I have these numbers. It's still going to multiply together to get 24. Okay? Let's do my prime factorization for 36. On this one, I'm going to do 6 and 6. Well, neither of those are prime numbers, so I need to break them apart. This can be broken apart into 2 and 3, which are both prime numbers. And then this I'm going to break apart also into 2 and 3, which are both prime numbers. So over here I have 2 times 3 times 2 times 3. Okay? Now, what I'm going to do is I'm going to look for the numbers in my prime factorization that they have in common. Okay, well I have a 2 here and a 2 here. And I have a 2 here and a 2 here. And I have a 3 here and a 3 here. But then these numbers aren't in common. So the numbers that they have in common are 2 and 2 and 3. Again, the order doesn't matter. Okay? So I'm going to do 2 times 2 times 3. I'm going to multiply together the numbers that they have in common. 2 times 2 is 4 times 3 is 12. And there's my greatest common factor. Okay? There's one other way that I want to show you. And this is the upside down birthday cake or the ladder method. Okay? So what I'm going to do is I'm just going to start by writing my 24 and my 36 side by side. I'm going to put an L underneath it. And I want to think, what's the smallest prime number that can come out of both of those? Well, it's a 2. Okay? So 2 from 24, or 2 can go into 24 12 times, and 2 can go into 36 18 times. Draw another L, and I'm going to do the same thing. 2 is my smallest prime number that can come out of both of those. 2 goes into 12 6 times, 2 goes into 18 9 times. Draw my L. Now, this time, I can't pull a 2 out of it. The smallest prime number that can come out of both of those is 3. 3 goes into 6 2 times, 3 goes into 9 3 times. And these are both prime numbers, so I'm done. Okay? Now, this is, it's called the L method or the ladder method or the birthday cake, because if you flip this, it's upside down, but it kind of looks like a layered cake or like a ladder that you're climbing up. Okay? Now what I'm going to do is I'm just going to look at these numbers going down. I'm going to ignore these 2 on the bottom. I'm just going to look at these numbers going down, and I'm going to multiply those together. 2 times 2 times 3 equals 12. So 12 is my greatest common factor of 24 and 36. The biggest factor that they have in common. Okay?